finds the value of y for which 1.01 to the power of y minus 1 is equal to 500. So I am going to take logarithms of both sides, where the base is 1.01. That gives me y minus 1 is equal to log of the base 1.01 of 500. Typing that into my calculator, I get 624.5629. Add 1 to that. So add 1 to both sides, and I get 625.56 to 2 decimal places. That's my answer for part I. Part II. Given that 2 log base 4 of 3x plus 5 is equal to log base 4 of 3x plus 8 plus 1, I need to show that 9x squared plus 18x plus 7 is equal to 0. So I need to get rid of these logarithms. The way to do that is to get all of the logarithms together on one side of the equation, so I can do the inverse of a logarithm, which is the power function. So let's go through this process. So I am going to move all the logarithms to one side of this equation. So subtracting the log base 4 of 3x plus 8 from both sides. I now want to try and combine these two logarithms together. So I have a single logarithm, and I am then able to do the inverse. I can't bring them together just yet because of that coefficient of 2. So I have to move that up to the power using the power rule. Now I've got to the point where I have the same coefficient of logarithms. I've got a 1 here, I've got a 1 here. So now I can use the subtraction law of logarithms, which allows me to bring these two things together with a division. At this stage, I have got the logarithm by itself. So now I can do the inverse of a logarithm to remove it. So I will have just x's. The inverse of a logarithm is the power function. In this case, because the base is 4, the power is going to be 4 to the power. So on each side of the equation, I'm going to do 4 to the power. On the left-hand side, 4 to the power of log base 4, well, they cancel out because, like I say, they are inverse operations. So that just leaves me with the subject, which is the inside of the logarithm, which is that. On the right-hand side, I've got 4 to the power 1, which is 4. All I need to do now is rearrange this to be in the quadratic that we needed, the form of the quadratic. So move the 3x plus 8 to the right-hand side, expands the brackets, and move everything onto one side of the equation, like so. So that's part A done. Part B says hence solve. So we're going to solve this equation, and then we just need to double check that our answers to this quadratic will work with the logarithm. So solving this quadratic, I'm going to factorize, but remember you could use your quadratic solver on your calculator, or you can use the quadratic formula. It is up to you. For me, I can see that this is going to be 3x plus 7, 3x minus 1. So x is either minus 7 over 3, or x is 1/3. These are the two solutions for this quadratic, but are they the two solutions for this logarithm? In particular, I'm focused on this negative here. X is equal to minus 7 over 3. I can see that that does not satisfy this condition here. X is minus 7 over 3 is less than minus 5 over 3, not more. And the reason why that's a problem is because if I substituted minus 7 over 3 in here, I would get a negative. 3 times minus 7 over 3 plus 5 is minus 2. And log base 4 of minus 2 is not defined. You can't do a log of a negative number. So this is not a valid solution to the logarithm equation, but 1/3 is. So that is the single equation, a single solution.